Hello, everybody. Yeah, my name is Ella. Maybe I will start by my story of how I ended up with Enapter, and then we'll continue at like what I'm doing there now. So when I finished high school, I didn't really know what to do, and I actually applied to engineering majors, but also for social work, so very different things. And then I don't even really remember the exact reason why I chose the major I did, which was called International Technical Cooperation, which was an engineering um, course. And over the years, I had parts of energy engineering and environmental engineering, but then also it covered aspects of management and like how to work in an international work environment. And so I studied this in Germany, but then I also went to Namibia for an exchange semester, and then also for my internship and bachelor thesis. And when I was finished, I actually wanted to go into the solar field. That was like what was most appealing to me. But I didn't really get in there. And then I ended up applying to a whole lot of different companies, none of them actually in the solar field. And also came across Enapter on LinkedIn and applied. Because the thing with renewable energy is that it's intermittent, and we cannot transition to 100% renewable energy without a means of storage. So that was my reasoning. Okay, this is still kind of solar. I'm gonna go with it. So that was about 2 years ago. Together with YT, I actually were the first two people in the Berlin office. Now we grew a lot, which is great. And so I started off as a project engineer. In the first year, I had two major projects on hydrogen storage and compression. For the first one, you can see the PNID here, like a very basic one for a hydrogen refilling station. So the idea was to use our electrolyzers to produce hydrogen at 35 bar, and then to store them at 700 bar to refill a fuel cell car. So these fuel cell vehicles normally are refilled at 700 bar. So you need to compress the hydrogen quite a bit to get to a certain distance, like a range you can cover with your car. So that was the first project. Then the second project, can you go to the next slide, please? Mauro or Sean or Lisa? Thanks. The next one was also on hydrogen compression and storage, because in our production facilities in Italy, we have, that one, thanks. We have a lot of tests going on. I mean, for one, it's the testing in the labs. It's the long-term testing to see how our systems age, but then also it's factory acceptance tests before we ship out the electrolyzers to the customers. So there actually is a lot of hydrogen being produced that we do not harvest in any way at the moment. But then at the same time, for tests as well, different kinds, we buy hydrogen. And that is kind of nonsensical. So the idea was, okay, we harvest the hydrogen we're producing anyways, store them at 35 bar as a buffer storage, and then compress it to 200 bar and to like save space for storage. And then we can use the hydrogen for pressure testing, like leak testing, for example, or for testing fuel cells, or also just to run fuel cells to generate electricity for our office. So yeah, those were the first two big projects I was working on, but then last year I moved more into device development for that, I would like to have the next slide, please. And so here you can see the two devices in whose development I was involved. The first one is the dryer. So our main product is the electrolyzer to produce hydrogen, but there are impurities in the hydrogen, but most of that actually is just water. And for certain fuel cells, for example, you need higher purity hydrogen, and for that we have the dryer. It's a mixture of temperature and pressure swing absorption. So there are two cartridges, and in the one cartridge, the hydrogen is being dried, while the other one is being regenerated. So we get to a purity of 99.999% by adding one of these dryers for now up to 5 electrolyzers. And then the other device you see is a liquid-cooled electrolyzer. So our standard electrolyzer is air-cooled. But then if you put a lot of electrolyzers together, there actually is a considerable amount of waste heat that gets generated. And you might want to use a liquid-cooled version where you can then harvest the waste heat and use it if that is helpful for your application. Yeah, so those are the projects I'm working on. As I mentioned, I'm based in Berlin, whereas most other engineers are in Italy. Last year I visited quite a bit for collaboration. This year that's not so easy, but yeah, so I'm working remotely with a team which is mostly working out quite well. And then this will change in the future when we have more and more engineering colleagues in Germany as well.